All right, here's our video today, Trigonometry, Algebra 2. Today we're talking about reference angles using tangent. So in previous videos, I talked about cosine, talked about sine, and other reference angles. So if you need to go back, just look at the links below. So let's get a clean page. Remember, we're dealing with the unit circle. Now remember, on a unit circle, let's draw it first. Draw the unit circle. And we're attempting to make a straight line. So on the unit circle, every radius that you create, right now I'm creating, let's say, a 30-degree angle. Every radius you make, every radii is 1. So we know that hypotenuse is 1, and we know this length here on the x-axis is 1. We know the coordinates will be 1, 0, because x is 1. And of course, this long line up here on the y will also be 0, 1, right? So we understand that. Now, with reference angles, we talked about before the 30, 60, 90 reference angle, and we talked about the 45, 45, 45 reference angle. So just going over sine again, if we have this 30-degree angle, and I made a line straight down to create a 90-degree angle, we have our 90-degree angle there. So we know that this is 30 degrees, because we just created a 30-degree angle, then this would have to be 60. And now we have our special triangle, 30, 60, 90. And in the 30, 60, 90, no matter how you draw it, right, 30, 60, 90, the hypotenuse will always be 2 times whatever A is, the A length, 2 times that. And the B will be the whatever the A length is times the square root of 3. So that's our reference right there. So if we look at sine theta, let's say, sine theta, I'm going to make another triangle over here. So let's say that was theta. We know sine is opposite. Remember, sine is opposite over the hypotenuse. So if this was just A and that was B, and the hypotenuse, we'll just put H, then we know that the and on a unit circle, we know it's 1. So the sine would be A over 1. And you notice that A is vertical. It's going up and down. That's the y length, the length of the y-axis. The length of this line on this triangle would be sine. Therefore, sine theta is always y. It's always the y coordinate. And cosine theta is the x coordinate. And I went over this in previous videos. So what would tan be? What would tan theta be? Well, we know tan is opposite over adjacent. It's what sine is over cosine. So it's sine theta divided by cosine theta. That's what tan is. Important to know that. So let's look at this reference angle, the 30, 60, 90 on this triangle. And let's try to find out what tan is. So, by the way, if you're trying to find the radians, if you remember radians, use a different color. You take 30 and you times it by pi over 180, which will give you pi over 6. So we know that 30 degrees is also pi over 6. So now, how do we get tan, and what does it even mean to get tan? So let me clear this out. Let's do it over. Rewind if you need to. And we'll stay with purple, why not? So we're going to make this line over here. We'll make our 30 degrees again. Okay, say pi over 6 or 30 degrees, whatever you want to use. And I made my triangle. So we have our 90 degree, we have our 30 degree, and we have our 60. And we're trying to find tan and what that would even mean. So what did we say was sine? Remember the reference angle. We have whatever a is there. This will be 2a, and this will be a square root of 3. So on our circle, we already know that that's 1. So A should be half. And because it's half, because double half is 1, right? It's obvious. And this would be half times the square root of 3, which is just the square root of 3 over 2. So we have our lengths, and we can say that this coordinate right here in green, this coordinate, put a little bit of line over here, this coordinate, the y is half, but the x is the square root of 3 over 2. So we know that sine is half. We know cosine is the square root of 3 over 2. And to get tan, we have to divide. We got to do half over square root of 3 over 2. We're dividing. So let's do it over here. We're going to do half divided by the square root of 3 over 2. And that means we'll put a little arrow. We're going to do half times, and we flip it, right? We do that with fractions, you know that. And now we can clear out the 2, and you're just left with 1 square root of 3. We're not done yet. Not done yet. Remember, when you see square roots, you have to rationalize the denominator. And we did it in the previous videos. All that means, though, I'm just going to do it simply for you here, is you're going to take whatever's in the denominator. If there's a square root in the denominator, bring it up, times it. Let's do it over here, get a little more room. Times it by that denominator. And what do you get? You're going to get the square root of 3, because 1 times the square root of 3 is the square root of 3. But over here, the square root of 3 times the square root of 3 is the square root of 9, which is a perfect square. So this final answer will be the square root of 3 over 3. That's tan. That's tan. We just found tan. Now, what does it mean if we find tan? Well, that's finding tan, and a lot of times that'll be the only thing you'll have to do. But if you have to do a geometric representation, geometric, right? What you see, geometric, that I'm going to show you that, like what tan looks like on the unit circle. So to do that, though, we're going to put it, I'll use yellow. See how yellow comes out. We're going to put a point here. We're going to make a line right on this that just touches the circle. And we're just doing a rough draft here. So remember, that's what tan does. It roughly touches the circle. And then you're going to extend the slope. You extend the slope all the way out. And this line that you created that just touches the circle at 1, 0, and then extends out the slope. I'll just put another dot there. This length is tan. This length is the square root of 3 over 3. So let me show you that again. Okay, here's a cleaner picture of it. And let's say right here that we had, in this case, it's angle alpha. It doesn't really matter what you're seeing. It just means we don't know what the degree is. So we're making our straight line down here. And then again, the tan line just touches the circle, as you're seeing it over here. And we extend out the slope of this angle. See how it's extending out? And so that from that point all the way to the x-axis where it touched, that would be the length. That'll be the height. That's the height. And that's tan. That's the tan that we're getting when we do sine alpha divided by cosine alpha or theta or whatever you're using. In this case, they're using alpha. It doesn't really matter what you use. So let's try one more. Oh, and by the way, tan will change. The measurement for it will not. The height will not change even if you're in the other quadrants. You might get a negative tan answer, but the height will always be positive. Just keep that in mind. All right, so here we have 330 degrees. All right, and the reference angle, though, is 30 degrees. So if you ever get questions of if you have 330, well, what's the reference angle? We'll just subtract from the x-axis. You know, if you do a complete circle, it's 360. So 360 minus 30 gives you 330. So the reference angle is 330. So when we want to extend out tan, I'll use green, why not? From this point on the circle, this point right here, we're going to have to, we'll make a straight line. So straight line, let's say that's a straight line. And then we extend the slope out. So then this point to that point would be tan, would be the length. That's would be the tan that we would get. And remember, how do we get it? We do sine theta or sine alpha over cosine theta. In this case, it'll be the same thing we got last time because it's a 30-degree reference angle. So it doesn't matter where you are on the circle. Even though tan could be negative, the height will always be positive. And I'll show you one where tan is negative. So let's look at this one right here. What do we have? And we'll change it. We'll use yellow. So opposite is A, right? Well, that's not working. Use black. Opposite is the A of the 30 degrees. Here's the hypotenuse, which we know is 1. And adjacent is over here, B. So let's just write it over here to see what we have. We know that's 1. That's 30 degrees. This has to be half. And this will be 1/2 times square root of 3. So this time the x, this coordinate over here, we already know that coordinate is. But this coordinate, what is that coordinate? Well, that coordinate for x we're saying is square root of 3 over 2. But is it positive? Yes, it's positive. But look at the y now. The y is half, but it's negative. It's negative half. So tell me what tan is. Pause the tape and see if you get tan. So remember, I'll do it over here. We're saying that sine is negative half. I'm going to divide it by x, right? Which is the square root of 3 over 2, just like we did last time. Put a little arrow there. So this is half, it's negative half, times, and we flip it, right? Do the reciprocal, and those cancel. And so we're left with negative 1 over the square root of 3. And don't forget to rationalize the denominator. Rationalize the denominator here. And we'll continue over here. So now we're going to have square root of 3 over the square root of 9. Don't forget we have negative there. And then this will be negative the square root of 3 over 3. So now tan has a negative, but for the height, there's no such thing as having a negative height. We'll still use that length, negative 3, the square root of 3 over 3. Even though tan, the answer for tan in the function is negative. So when you're looking at reference angles, we have the 45, 45, 90, and the 30, 30, 60. You can get the trig function, the answer for the trig function, and you can also show how you can get the representation of tan by doing these reference angles. And one last thing, you can see, if we get my pen going, we'll make another unit circle. All right, and as we increase the angle, you'll notice that tan will increase, right? We're increasing this angle over here. So remember, we have to have this straight line from the x-axis. Have this straight line going up. I'm going right off the screen now. Now we have to take the slope and match that. So you have to make the same slope and match that. You see how I went off the screen there? But so the length of tan will increase as you increase the degrees in quadrant 1, right? As you increase the degrees, but once you get to 90 degrees out, it's be undefined. It's undefined. So undefined means it just cannot be solved. So you should remember from your math classes that vertical lines are undefined in functions. And here's a better picture of the 60 degrees. As you can see, right, we're trying to match the slope. Slope's going all the way up. We go off the page. You see how long this maroon purple line is, which will be the height of tan. And again, how we got tan? How we get tan is we take, make sure our pen's working. We're going to take whatever sine is, theta, and we divide it by cosine theta. And we get tan theta or tan alpha or whatever you're using. All right, that's our video today.